So the idea is that you're going to fire your rocket with some velocity v number 1 into the package, giving it some velocity this way, v number 2, that's big enough that when it falls down, that it's going to go to the Explorer and not into the water. So it seems like the first thing that's going to happen is we're going to have conservation of momentum. So we have our chart, and we have the rocket and the package. And before the rocket hits the package, it has some momentum, which would be mass of the rocket times v1. The package has nothing. After the rocket embeds himself in the package, it's going to have momentum, mass of the rocket, velocity number 2, and the package is going to have the same velocity, different momentum, except different mass. So we do our conservation of momentum. We find out that mass of the rocket times velocity number 1 is equal to mrv2 plus mpv2. So now if we only knew what v2 was, we could figure out what v1 is. And finding out v2 comes from the spaghetti water problem. In this problem, we know the horizontal distance x that the package needs to go, 30 meters. We know the vertical distance y, 200 meters. We know that in the x direction, it's going to have constant velocity, x equals vt. And in fact, the v is v number 2. And in the y direction, we have y naught plus b naught t plus 1/2 gt squared. But we know that this is 0 and this is 0. So y is just equal to 1/2 gt squared, which means that t is equal to the square root of 2y over g. And since we know y, we can calculate this time. And then we find this time, we can stick it in here with the x that we know. And then we'll have this velocity number 2, and we can stick that in here to find finally this velocity number 1, what the problem asks for.